Good afternoon, everyone. Namaste. I welcome you all to the National Conclave on India's Sustainable Development 2021. The conclave is being jointly organized by College of Engineering, Fulton Education Society, Maharashtra, and Indian Youth Nuclear Society. I extend my warm welcome to our esteemed chief guest of the program, Shri Ujjwal K. Barwaji, Project Director, ITER India, Institute of Plasma Research, Gandhinagar, and our panelist of the program, Mr. Anuj Bhatnagar from Bureau of Indian Standards, Mr. G.K. Pillai from Volchand Nagar Industries Limited, Pune, Dr. V.N. Ojha, retired scientist, CSIR, NPL, Delhi, Shri S.K. Malhotra ji from Indian Nuclear Society, and Nitendra Singh ji, President, Indian Youth Nuclear Society. I also welcome Dr. Ajay V. Deshmukh, former Principal, Fulton College of Engineering, Pune, and Director and Visiting Professor as Bhaskaracharya Pratishthan, Pune. Realizing the significance of Honorable Prime Minister Narendra Modi's inspiring call during the United Nations General Assembly 2020 on Atmanirbhar Bharat, that is self-reliant India, to all citizens of India to join hands and make the nation self-reliant and a great economic power, the organizers decided to have a lecture and a panel discussion with the experts from the industry, academia, and research domain. The main aim is to emphasize on the issues of energy security in India and significance of standardization and calibration in the Indian industry. This event is of notable importance for the students, academicians, researchers, and the industry professionals to encourage them with a vision towards national development. Both the organizers, Fulton Education Society, College of Engineering, Maharashtra, and Indian Youth Nuclear Society, have been working in this field, promoting and educating students in this field. So, without taking too much of time, I would like to now request Shri Ujjwal Barwaji to say a few words, and before he starts, I'll give you a short preview about him. As I told, Shri Barwaji is the project director, ITER India, and he is presently the director. ITER India, the Indian domestic agency for in-kind deliveries to ITER, the international research collaboration, which is being built in France. His prime research interest involves development of neutral beam injection system and electrical power converter for its operation and control. He is also leading the Indian team to deliver several complex engineering systems, many of them first of a kind on ITER. He graduated from Assam Engineering College and went on to do masters in electrical engineering from IIT Madras. And he has been with the Institute of Plasma Research at Gandhinagar for the last 25 years. So now I would like to request Shri Barwaji to please give his speech.
The nations has set up for all its countries uh, and what they call something like, I think, Sustainable Development Goal of Agenda is to 2030. And that is itself is a big goal, and I think they already have within that some 16 or 17 goals identified, which essentially looks for well-being of everyone, reduction of poverty, uh, and so and so. It also talks about growth and innovation. It also talks about gender equality and reach of education. It talks about health and sanitation. It talks about inequality, peace, justice, and almost everything, whatever is required for a better sustainable mankind. It also has a specific goal in energy, because we know that energy is a goal, because energy is a key indicator of how a civilization is active, what it is doing to its fellow citizens. But then when you talk about particularly for the younger generations, this sustainable, many of these goals you will find, or I must admit, myself find quite sometimes very big words. Sustainability is, in simple words, for me, actually, if I look back when I was a student and staying in the hostel, we had a limited access to money that came in the first of month or second of month, and by probably first week of the month we used to live like a king, and then it becomes really unsustainable for us. We have to go on borrowings from someone else, and that is. But then now probably I can manage that unsustainability of financial front for myself better. That is just an example. What sustainability is means. You have some resources, you need to use it judiciously. You need to use it judiciously in such a way that not reducing it, not merely reducing it. Not we are not talking about reducing the consumption of energy, but using the energy in a more responsible way, so that larger and larger section of society has reached to a energy of some kind. Uh, so when it comes to all the sustainability, different people do it in a different areas. Economists do it from economic funds. Managers work in on managers fund, but particularly me and people who are on the panel today, it is more important that how the roots of all these causes boils down to some technical issue. This is what is the point. And when we talk about the energy, it's a, we know that energy resources are limited. But then in the last few years, you might have seen that there is explosion on using solar energy or wind energy and that kind of renewable energies, different forms of renewable energies. In a big
Sound is not there. Yes, now it is coming.
As 2020, Nitin, Dr.
Sure.
Nitin,
Yes, sir.
and
Has he
and
joined
fusing
any?
the atoms, fusing the atoms of hydrogen and taking a little bit of energy out of it, out of the atom. This is what we are doing in our modest effort as a part of a big project, scientific project among 7 countries, which the project is being built in the south of France, the place called Cadaras. The project itself is known ITER, International Thermonuclear Research Experiment. Anyone can look at it, more the details in the more about its details in the website. What we are trying to do is we are trying to see that in future, when all other forms of resources become constrained, we are not talking about only few hundred years. Uh, we need to somehow replicate the same source of energy as the sun is producing, that is fusion energy. And for us, it is not going to be very simple. And this is what brought some 40 countries all around the world in this collaboration. And India, being a responsible member, fully committed to sustainable development of all nations, all mankind, not only not only for India. Uh, eh, so we have become a partner to this program, uh, and we are delivering quite some things as in-kind contribution, essentially building the machine. When it comes to building the machine, I can definitely see that while the effort is for sustainability, but I can definitely see the role of measurements, engineering measurements, and standards. This is where I think this is talk today, the panelists will discuss more into that area. How do you, how standardization helps in the long run to build something which is going to be sustainable, which is going to be helpful for all people to use in future. In the particular case of us, we can always say that there are components of the big machine, big project being built at different countries. And how do you ensure that what part I send there, how does it match to something which has been built in France or something another, still another which is built in USA? So all this goes to boils down to the fact that we are following certain standards, and certain standards are mostly in our European standards. Even though equipments are first of the kind, we are trying every time that adopt certain standards to the extent possible and go on building it around that standards. This has helped us tremendously in the building of the systems that is for our research. And I understand this is similar things are not new to the only us. It is a universal practice where standardization builds a basic of once the engine's basic scientific principles are established, then the rest of the things are engineering. And when at that level of engineering, you need a huge effort in standardizing everything to make it reliable, to make it more economical, and so that it can be used by many people. So this is what I would say a great effort. And in our panelists today, we have colleagues from the nuclear energy sectors. Probably they will speak about how Indian nuclear energy sector is depending on the standardization. We have Mr. Bhatnagar from the Bureau of Indian Standards, who are the people who looks into the standardization factors of all equipments, not only the nuclear, all other equipments, all other systems that we use in our daily life. We have industry representatives who are known to have a flair in not only nuclear, they are into aerospace, they are into defense, they are into transport and many others. and lot of industrial practices, experiences they have, and also we have the person from National Physical Laboratory who are the repository of organizing the how do you make measurements in India and how to standardize things from the technical point of view. And I would say this will be an interesting discussion I am looking for. And I think the audience, particularly the students and younger professionals, will greatly benefit from this. Probably I will stop here with this introduction only. It is over to you, Nitendra, and the panelists to start the session in the right earnest. Thank you. Thank you.
Thank you, Shri Ujjwal Barwa ji. You gave enlightening information on the work being done at ITER India. And as you mentioned about the constrained resources of the future and the important role of research being done at ITER France, I consider that the future depends upon sustainable development, and the faster the nations realize this thing, the better will be the future of the coming generations. As the present scenario, we can see a little hidden, unknown, invisible virus has all, closed us inside our doors. So the future depends upon the type of clean environment we are going to give to the next generation. As you also mentioned about the reliability introduced by maintaining standards and calibration in industrial and energy sector, I'm sure that our next panelist, being moderated by Dr. Nitendra, will be throwing good light upon all these sectors. And I hope that as an Indian, and as we can see the present scenario of the research being done at India by NPL, I am sure that we will be having good future for the next generation. So now I hand over the proceedings to Dr. Nitendra for moderating the panel discussion. Thank you so much, sir. Nitendra?
Thank you. It's my pleasure.
Thank you, Dr. Raji, for giving me the responsibility of moderating this esteemed panel. And thank you, Barua sir. You have actually rightly mentioned the few important aspects which are really important, and people are really unaware about these. Especially when you highlighted the UN SDGs, as we say, Sustainable Development Goals. I would say most of them are applicable, and we need to work in our country, whether it's healthcare, whether it's energy, and so on. That the list is really big. You have mentioned the 17. So this is one of the idea with which we started actually thinking about this event. And I would like to mention here that Dr. Rajiv and Dr. Deshmukh were the key person who actually came up with this idea and decided to bring this sort of discussion so that people can understand what this is all about. And as you have understood by now, that as title mentioned and Dr. Rajiv has also highlighted, the discussion will continue mostly around the standardization, measurements, the growth of industry development, energy security, and all around. However, the people perceive it in a different manner. Whenever you discuss about these three topics, they seems like three different lags and nowhere connecting to each other, and everyone feels like that. Okay, this is the responsibility of this one, this is the responsibility of industry, energy will be taken care by someone else, so it's nothing with us. However, I feel in a different manner, and I found like, let's bring it the experts from these fields and see what this is all about. And as far as I understood this topic of sustainable development, I found like sustainable development mainly depend on three aspects. One is money, because this is something my dad used to say: money is movement. You have money, you can move, you can grow, you can do anything you want. So money is very important. And the second is energy. Because if you have money but you don't have any energy to do anything, you can't do anything. So somehow again, the energy is equally important in that factor. And third very important factor we mostly ignore is the time. We don't see like even if trivial growth or development is done, say for example in 10 years or 100 years, it's useless sometimes. However, if you want to do some sort of a huge development or huge leap in some technology or in any kind, and you do it in a small time, then you need a high amount of energy and money into it. So all three things are coupled. So if you see, these three pillars are here only. Like if you figure out, the money is mainly generated by our industries. In any country, the money is basically governed and generated by our industries. So we have the pillar of industry here in our panel. We have I'll introduce the panelists in detail, but we have an industrial representation today. We have energy representation. We have people from the energy industry, and not only the normal energy industry. We are here talking about the nuclear sector or the renewable energy as a whole. Why nuclear energy or renewable energy? Because as we all know, we are living in a climate emergency. We don't realize it, but it's a fact that we are living in a climate emergency. The climate change is at its peak, and we are deteriorating the situation day by day. So somehow we need to intervene this situation. We need to stop it, like somewhere that we can contribute now to at least reach to carbon neutrality. How much we are generating, at least absorb that, then we can think of going down. So in this way, the importance of the clean energy becomes very very important. And that's why we are focusing more on having the base load capacity of clean energy. And in that scenario, nuclear energy is the promising candidate. So we have a pillar from energy scenario, and time in a different perspective we have brought in here. So time, we are not talking about this time in as a whole, but here time is basically we are focusing on standardization and measurements, how we can reduce this time. The things which we are talking about, the development which we are talking about, how fast we can go, how quickly we can deploy that sort of things which we have. So that's how we will be going to discuss today. So let me take this opportunity to introduce all of you with the esteemed panel which we have today. So we have Shri S.K. Malhotra, who's presently the Secretary of Indian Nuclear Society, which is the official organization from Department of Atomic Energy, and he is very well connected with nuclear science and technology for last 45 years. After his post graduation in chemistry from Agra University in 1976, he joined the esteemed Bhabha Atomic Research Center. And for more than 2 decades, he was engaged in research and development on heavy water, which is an important aspect of Indian nuclear program. And since 1999, he was appointed as head of the Public Awareness Division of Department of Atomic Energy. And he eventually became a great science communicator, I would say. And he superannuated from DAE in 2015 as an outstanding scientist. And since then, he has been appointed as the secretary of Atomic Energy Education Society, which is also the autonomous body of DAE, and was also awarded with the Raja Ramanna Fellowship in 2019. Uh, in 2020, recently, he was elected as the secretary of Indian Nuclear Society, and he has widely traveled person and delivered a lot more than 500 invited lecture on several topics, and also contributed 2 books. So Mr. Malhotra has also been bestowed upon the many awards by the Department of Atomic Energy, and he has been a fellow writer of Indian Science Writers Associations. So we welcome you, Malhotra sir. Thank you for joining us. Then we have Shri G.K. Pillai, who is the director and advisor of Walchandnagar Industries, Pune. Mr. Pillai presently is the director and advisor of Volchannagar Industry and is an acclaimed management leader. And he is very well known both in name and public sector, in both the public sector and private sector in the industry with total of 47 years of professional experience. Graduating from BITS Pilani in 1973, Mr. Pillai started his professional career with the Instrumentation Limited, Palakkad in Kerala, as a graduate engineer trainee and worked till 1994, where he held the position of Deputy General Manager. Years after which he ventured into private sector to work at Fisher Sanmar Limited in Chennai, where he rose to become the chief executive and later took over the another US joint venture, Tyco Sanmar Limited, Chennai as the CEO. In 2007, he took over the reins of a heavy engineering corporation limited, Ranchi, as the chairman and managing director, where he steered the company out of the red with some innovative management initiatives. In January 2011, Government of India appointed him as the CMD of HMT Machine Tools Limited, Bangalore. There too, he significantly improved the overall company's performance. After superannuating from both these organizations in 2011, Mr. Pillai joined one of the India's most famous engineering group, Walchand Nagar Industries Limited, as the managing director and CEO, and continue his position for 8 years. He received several accolades for his impeccable contributions to the development of the industry, and he is also a keen speaker, delivering various talks in national and international symposiums, and also to educational and training institutes all over the country. We warm welcome you, Mr. Pillai. Thank you for joining with us today. We have with us Dr. Ojha today. Dr. Ojha superannuated as the senior most chief scientist of CISR National Physical Laboratory. He was the head of time and frequency and electrical and electronics metrology division, and he was also the head of environmental and biometric metrological division, head of expex level standard and industrial metrology divisions, and also the ex-professor of physical science at ACSIR. He has more than 36 years of laboratory experiences, 100 plus research papers, and delivered 120 invited talks in several proceedings and related to the field of metrology, ISO, and quality. He has conducted many workshops and training and trained more than 5,000 industrial personnels, laboratories, and within the SARC nations. And he has two US patents, and two are still in process. One on technology of PM25 of pollution measurements, which has been transferred to industry, and two copyrights has already been granted in process. He has been awarded with several accolades, including the first Indian and probably second in the Asia Pacific to receive the award of outstanding contribution to the development of metrology in your economy. He also received the Young Scientist Award from CSIR and in 1992 by the President of India at that time, Dr. Shankar Dayal Sharma. Oh, he has a list of accolades with him, and warmly welcome him to be on this panel today. Thank you so much, sir. The one more panelist who is working in the area of Bureau of Indian Standards. Earlier, we know everyone like ISI mark thing which is available. It is basically the Bureau of Indian Standards. So we have Mr. Anuj Bhatnagar.
Thank you. Good afternoon, everyone. Before I start my discussion, uh, I'm supposed to continue.
Sure, sir. Continue, please.
Yeah. As I was telling, I thank IYNS, the younger version of INS, which I represent as secretary. And I also thank Dr. Nitin for this initiative and particularly inviting me to today's proceedings, which is very important. I register my gratitude and greet everyone present uh, as panelist, as organizer, or as simple audience. So see, you already heard about today's event, what it is about. Yes, when first time when I heard that they are going to speak about sustainability, energy, I mean, good, sustainability and energy very much interconnected. And then he started telling standardization and calibration. I was lost for some time. In fact, I spoke to Dr. Nitin about it, that what exactly do you mean by this interconnection between these things? Anyway, in my 15 minutes, whatever I am going to speak to you, you can divide it into three parts. I think first 5 minutes or so, 5-6 minutes, I will speak about sustainable development and energy, and particularly the role of nuclear in that. Then I will switch over to, I think, as I was advised by the organizers, to speak for about 5-6 minutes about a relationship between import of either equipment or raw material or resource material, whatever it is. That means the connection between import and energy security of the country. And at the end, for maybe about 4 or 5 minutes, I will present my views on role of standardization in energy security. And here I'll be restricting myself to nuclear. So in the middle part, that is when I am speaking about import versus energy security, I'll be essentially talking about all resources of energy. So to start with, let us talk a little about sustainable development and energy. As Dr. Barua in his inaugural speech mentioned, maybe I'll be slightly repetitive. So as he mentioned that in 2015, the United Nations adopted 17 sustainable development goals, of course, popularly called SDGs, to be achieved by 2030. Out of these, SDG 7, that means the seventh goal, is about ensuring access to affordable, reliable, sustainable, and modern energy for all. And for all means for everyone on the planet. This goal is also directly or indirectly important for achieving the other 16 goals too. So in fact, providing energy to all is very important in the success of this SDG program, overall program. Now, having said that, naturally we need a lot of energy because on this globe, there are at least 1 billion people even today who have no access to energy of any kind. Energy means electricity, I'm talking. When I say energy, I'll be restricting myself to electricity. So I think there are about 1 billion people on this globe who have no access to electricity. And I think by the time we will try to provide electricity to them, there will be 1 billion fresh people who also will have to be provided electricity. I have taken care of, I mean, when I say 1 billion fresh people, this is birth minus deaths. So that means by 2030, we need to provide electricity connection maybe for the first time to about 2 billion people. So that's one challenge. And the second challenge is the impact of providing energy in so large amounts on the climate and the temperature of our planet. I think everybody knows, I don't have to discuss or prove that climate change has become a global emergency, and for sustaining life on our planet, it is essential that global warming be restricted to 1.5 degrees centigrade by the beginning of next century. I think we need not discuss this. This is a well accepted fact. In fact, the other day I was listening to a lecture by Dr. Anil Kakotkar, my former boss, and in that he, in fact, it was an information for me that recently, I think in the recent past, some survey has been held by United Nations, and in that, across the globe, and in that survey, it has come out very clearly that more than 2/3 of the people surveyed, they agree with the fact that climate change is the most important global emergency the world is facing. So as I told you, for achieving that 1.5 degree temperature as compared to 1.5 degree increase as compared to the pre-industrial revolution temperature, for achieving this, we need to cut our greenhouse gas emission gases by 45% below the 2010 level. We have taken 2010 level as the base level by 2030. So, I mean, from starting from 2010, in 20 years, the emission has to be brought down by about 45%. And by 2050, in fact, it has to be brought down to zero. If we want to restrict the temperature increase to 1.5 degree, the emission must become zero by the middle of the century. No doubt, under this compulsion, renewable energy is very important and inevitable option. I mean, you can't really achieve this without renewable option. So I think step number one to this direction is that in every nook and corner of this globe, wherever, whatever kind of renewable energy we can exploit, it must be exploited. I think that is going to be a very important step, and please take it seriously. A nuclear scientist talking about renewable being the first and the foremost. That is very, very important. No potential available to us in terms of renewable should be left unexploited. But having done that, or working in that direction, doesn't mean we can become complacent. It is not going to be enough. Whatever renewable energy we add, it is not going to be sufficient. So we need to supplement and complement it by nuclear power, which can make vital contributions to decarbonization while delivering large quantities of base load electricity. See, this, I think many people, they feel that nuclear is competing with renewable. I think I want to clarify once again. I think I have done it umpteen number of times. Once again, let me attempt to my dear audience that please note that there is no competition of any kind between the nuclear sector and the renewable sector. In fact, both must work together, complementing and supplementing each other holding hands of each other, because our goal is same. Our goal is decarbonization of the world economy, not merely Indian economy. Because decarbonization is one thing, where a nation doing it, a section of the society, a continent doing it is not going to happen. Carbon dioxide. In nuclear energy, we say uh, any accident anywhere in nuclear industry is accident, should be treated as accident everywhere in nuclear industry. So similarly, I would say any carbon emitted during energy production process, any carbon emitted in any country or in any continent or in any city, it is carbon emitted anywhere, because unfortunately the carbon dioxide molecule does not recognize, does not respect, and does not restrict itself to geographical boundaries. It sees Earth as one entity, and a carbon dioxide molecule emitted from USA can do as much harm to India as to USA, and vice versa. So this we must understand, and that is why it is very important that the nuclear sector, together with the renewables, they join hands with each other to bring down the or to effectively bring about decarbonization. Now, if we talk of India, like many developing countries, we also have the twin challenge, which I already mentioned. What is this twin challenge? First, to meet the increasing energy demand, that is, I think if you compare with today, by middle of the century, we need to increase our energy generation by 4 to 5 times by 2050. And what is the second challenge? That while doing so, keep pace with the rest of the world in decarbonizing the economy. So while putting up these additional energy production plants, we have to take care that we are not adding to carbon emission. And in fact, whatever are the existing plants, we need to, if not to make it net zero, we need to minimize the carbon emission from even our existing plants. So this is going to be very important. For increasing our per capita annual electricity, I think somebody's mic is on and there is some disturbance. Dr. Nitin, I will, or organizers, I'll request you. I think at some audiences, mic is on and there is some disturbance, some noise. If it can be kindly taken care of. Okay, so returning, for increasing our per capita annual electricity consumption from the present 1,200 kilowatt hours per person per year to about 5,000 kilowatt hours by the middle of the century, we will need to enhance our electricity generation from the present about 1,600 billion units per year to 8,000 billion units per year. And that is why, if you remember, I said that we need to increase our energy generation from 4 to 5 times. Actually, if you take this 1,600 billion units to 8,000 billion units, it is exactly 5 times. 50% of this, now, if you do some back of the envelope calculation, 50% of it can come from renewable resources. And the rest 50% has to come from base load capacity, which will need to be doubled. And for this purpose, it will need to be doubled. That means 4,000 kilowatt hours has to come from base load capacity. And base load capacity today is about 300 gigawatt in India, or 300,000 megawatt. Okay. It has to be doubled to 600 gigawatt. And this will, I mean, if we again go to that back of the envelope calculation, this will mean about 30-fold increase by 2050 That means in another 30 years in both renewables and nuclear. So both renewables and nuclear must multiplied by must get multiplied by 30 folds. Still there will be balance left. And that balance will have to come from fossil fuel, but with a difference, that is, while managing carbon dioxide, carbon capture, carbon utilization, and sequestration. Anyway, I will not go into the details of this. So friends, these were my thoughts about the sustainable development and the various types of energy. And we definitely, in a very serious mode, we have to work on this. Definitely, we need to increase our energy production. And while doing so, we need to ensure that we do it in a sustainable manner so that forget about everything else. At least the life should be able to sustain on this planet. So that becomes very important. Now, my second topic, which I already mentioned, is about why we rely on import for energy security. You know, on one side, we say that we want to make India as, secure from energy point of view. Now, if you want to make our country secure, definitely the dependence on other countries should reduce. But we see that in every sector, we are importing things in the name of becoming secure in the field of energy. Be it coal sector, we are importing, forget about the components, we are importing the raw material, coal itself. If you take the year 2019, I think we imported 200 million tons of thermal coal. Thermal coal, which is basically used for generation of electricity, not for metallurgical applications. That is that coking type of coal. So I am talking of thermal coal, which is used for energy generation. So I mentioned in 2019, about 200 million tons of such thermal coal was imported, as against 600 million tons, which was indigenously mined. So that means whatever thermal coal we are using for electricity generation, good 25% we have to import. Now we have to import so that we are secure in we have the energy security. But at the same time, I think you might have read in newspapers that at certain power stations, it became hand-to-mouth situation. They said if in another week the ship of the coal doesn't arrive, there will be no coal in a given power station. So these kind of situations are coming because unfortunately, coal is required in such large quantities. For 1,000 megawatt plant, you need about 10,000 ton coals every day. If you are running a 1,000 megawatt plant, which is a small plant, not a very large plant, you are talking of gigawatt capacity. So just 1 gigawatt plant based on coal, if you want to operate, every day you need 10,000 tons of coal. So naturally, how much you can hold, how much stock you can maintain in the power station? Maybe for 10 days, 15 days, not more than that, because for every day you need 10,000 tons. And for bringing 10,000 tons from either the coal field or from the nearest port, you need to use goods train. So for bringing 10,000 tons, you need to bring 5 goods trains every day. So please note the land required for storing the coal and the transportation infrastructure required for transporting all this coal. So naturally, if you are too much dependent of import of coal, no doubt it will provide you energy security, but it will also culminate into the system and insecurity, in the sense that if the coal doesn't come by a given time because of some political situation, some climatic situation, some accidental situation, um, if the coal doesn't come for, let us say, a few weeks, you are subjecting your country to a insecurity. So I think this should be looked at. Now, India's thermal coal import, that, as I already told you, it rose by 12.6% in 2019 by about 200 million tons, as I already told, against 600 million tons indigenous production. Of course, now the scenario is likely to change because, as you know, in the middle of 2020, Indian government has offered coal mines to private sector, and I think some auctions are taking place. And altogether, I think Indian government wants to offer about 41 coal mines to private sector. So maybe with this, the indigenous mining will increase, and probably the dependence on import of coal will reduce. Now, I think so much so for thermal energy. I'm really not an expert of thermal energy. I mean, of coal-based energy. Now coming to renewables, despite Indian government, see, everybody talks goody about renewables. They must be encouraged. Government is also supporting. So coming to renewables, despite Indian government's commitment to clean energy, its investment in clean energy, actually, I mean, I'm sorry to tell that it lags behind the ambitions. Our ambitions, the government's ambitions are too high on renewable, but allotment of fund doesn't match those ambitions. I'll give you an example. Again, in the middle of 2020, it announced various stimulus packages for stimulating the Indian economy. One of them was it allotted about 1,70,000 crore rupees to support the energy sector. Total amount sanctioned to energy sector was 1,70,000 crores, out of which hardly 9,500 crore, means less than 10,000 crores, out of 1,70,000 crores. Only 9,500 crores is for green energy, all green energy put together. It amounts to about 5%, 5.5% of that package. And the lion's share, where has the lion's share gone? The lion's share has gone to the fossil fuels and to the discoms, means distribution companies. So you can say a major share of this money is going to be spent on fossil fuel based energy systems and on distribution companies. And only 5.5% is for the so-called green energy. And we say we are going to go all out about green energy. Now let me take these renewable resources one by one. Solar energy in India, it heavily depends on import of wafers, cells, and modules. And majority of these imports are from China. So of the 2.5 gigawatt demand in 2020, we added 2.5 gigawatt capacity in solar PV. Out of this 2.5 gigawatt, only about 15% was met through domestic manufacturing. The remaining was predominantly sourced through China. So we are advising general public not to buy toys, not to buy patakas, not to buy pichkaris on Holi from China. But the fact is that almost 85% of our solar panels, cells and modules in 2020, they came from China. Indian manufacturing capacities are actually very subscale. It's not that they are producing and we are not buying. Actually, that production capacity is not there. So it is really subscale. Average plant size in India is 0.5 to 1 gigawatt worth of solar panels, as compared to 3 to 5 gigawatts in China. Individual manufacturer minimum capacity is 3 to 5 gigawatt in China, and in India, in most of the cases, it is 500 megawatt. Hardly in some cases, it is 1000 megawatt, that means 1 gigawatt. Despite a 15% safeguard duty, now India has, Indian government last year has imposed an additional 15% safeguard duty on Chinese solar modules, but they are still, despite this 15% duty, they are still cheaper than the Indian ones. India should intensely focus on cell and module manufacturing, as more than 70% value addition happens at this stage. Somebody is trying to say something. Can I continue? Okay, since there is...
Sir, couple of minutes, yes.
Yeah, okay.
Thank you.
I understand. I think I have covered more than half. Yeah. Anyway, I'll increase my pace. So where was I? Yeah. So we need to accelerate generation of solar modules, solar PV cells in the country. Now, talking of wind, India has, the situation is slightly better as compared to coal. India has 300 gigawatt onshore potential and about 200 gigawatts of offshore potential, and India has begun to just scratch the surface of this. We are only at the tip of the iceberg. India plans that by 2022, its wind capacity will be about 60 gigawatt out of total 175 gigawatt of renewable capacity. And by 2030, the wind capacity will be about 140 gigawatt out of total 450 gigawatt of renewable capacity. The wind supply chain is already localized in India to a good extent, to the extent of 80 to 85%. Major components being imported are limited to castings and power electronics. Now, finally, coming to the nuclear sector, which is, my field of work. So coming to the nuclear, we have a unique and robust 3-stage nuclear power program. I think most of you know, with pressurized heavy water reactors as the flagship reactors for the first stage. We have 18 of them operating. I think I will cut short. I had given a statistics that out of 18, how many are of how many. So these 18 PHWRs and together with 4 light water reactors, our total installed capacity presently is 6,780 megawatts. So about, very close to 7 gigawatt. And we are constructing some more. The PHWR technology, PHWR means the pressurized heavy water reactor technology, is a perfect example of Atmanirbhar Bharat. We have not started doing it since 2020 when Atmanirbhar Bharat was announced. We have been doing it for time immemorial, from the beginning of our program. So, in fact, can be considered as this PHWR, not only it is for Atmanirbhar Bharat, it is considered as a reactor which is ready for export to other countries. Only constraint in expanding this number of PHWRs can be limitation in the availability of indigenous uranium. Yes, we have modest resources of uranium, though if you look at last 15 years, our colleagues at Department of Atomic Energy, they have added fresh resources of uranium, but still we have to import uranium. We need to import and build up. So what is required here? Now you compare the scenario with import of coal. You have to import coal also, and you need to import uranium also. But what is the difference? As I told you, for every 1,000 megawatt, you need to have 10,000 tons of coal every day. Against that, in a nuclear power plant, for a 1,000 same 1,000 megawatt plant, if it is natural uranium, you need about 160 tons in a year. 160 tons in a year, compare it with 10,000 tons every day. So that means you can hold uranium much more easily as compared to coal. You can hold it for long periods of time. So it can, so you buy, if uranium is available today at cheap cost or whatever cost, you bring it today, maintain the stock. So maybe for many years to come, it is possible to store that much uranium in the country. So it will provide you mid-term or long-term energy security. So that is the difference between import of uranium and import of coal. Another advantage of importing uranium is the multiplier effect, as I call it, the multiplier effect of uranium. If you are importing coal, you can burn it only once. Once you burn it, it turns into ash and carbon dioxide. You can't reuse it. But in case of uranium, whether it is natural uranium or enriched uranium, if you are importing, when you make fuel out of it and put it in a reactor, you will be producing electricity. And the spent fuel, if you reprocess, you get fuel for the future reactor. So this is what I called as multiplier effect of uranium. So this is another advantage, that if you are importing 1 ton of uranium, you are not just importing 1 ton for the present program. Out of this 1 ton, hardly 0.1 ton will be used for the present program. 99.9 tons will be for the future program. In addition, we are already having four light water reactors. 2 of them are boiling water reactors, the good old Tarapur 1 and 2, General Electric, and 2 of them operating at Kudankulam, which belong to the pressurized water reactor category, which we built in technical collaboration with Russia. And we are going to build a few more, and we are going to build a few more light water reactors with some other countries. I will not go into the detail of both. So there is going to be import of not only uranium, there is going to be import of reactors from other countries. I'll come back to this. Then we have the second and the third stage, which is at present at the developmental stage. So I think it is few decades. So since we are generally talking up to middle of the century, I think only second stage will make it and will start making contributions to Indian electricity scenario by the middle of the century. The third stage essentially will enter into commercial domain only after the middle of the century. So I'll not talk about it. Now, I think this was about the energy security and import of material. Now I come to the concluding section of my today's thoughts, which is about role of standardization in energy security. So I think very quickly I will tell you about this role of standardization in energy security. I'll be confining only to the nuclear sector because I think I have knowledge. I will not say sufficient knowledge. I have adequate knowledge, a little less than adequate maybe, only in the nuclear sector, in which I have been around for last 45 years. As already mentioned, 10 numbers of 700 megawatt PHWRs have been approved for construction in fleet mode. Now, when you construct in fleet mode, there is an advantage. This will result in standardization of design of all major and minor equipments and will bring down cost and gestation period. This will also hold true for the second and third stage reactors, which are going to be our indigenous reactors. Once the design is standardized and large scale deployment takes place, so you take advantage of that fact. And the industry also, it is good for industry. I think it makes sense. It brings down the cost. It reduces the gestation period. As far as now, let us talk about the reactors being put up and to be put up in collaboration with other countries. So essentially the imported reactors. What about their standardization and how do we standardize? our objective, see, there is no problem. You are importing reactors from other countries, you import, but try to make India as the hub of manufacturing. I think we should take a cue from what happened to auto industry in India. I think I always give an example. In last 30 years, whatever has happened to the auto industry. In my childhood, if you book a car, if you have got money, you book a car for 10 to 20 years, your turn doesn't come. From that, we have come to a situation that you go to the market and purchase the car of your choice if you have got the money. So this situation, I think India has become a very important manufacturing hub for a variety of cars. All global cars are being manufactured in. So I think my dream is that in India, while importing reactors, we should go for indigenization of the technology, and maximum components of these imported nuclear plants should be manufactured in India. This will be a win-win situation for Indian manufacturers and also for the Indian industry. I think in view of constraint of time, I'll restrict myself to these comments. Thank you for your patience. I think for the time being, I stop talking here. Thank you once again.
Thank you, sir. Thank you so much for this elaborated information you have given. I think this was very much needed. And before I continue, I would like to mention here that you have highlighted this point, like nuclear industry in India is one of the great example of actually the Atmanirbhar Bharat, or you call it Make in India or something, and which is not from today or 2020 or 2014 per se, but it is there since its inception.
Oh, yes.
So yes, and you have highlighted a great thing, like we need to give electricity or energy to 2 billion, and that not for one day, but for continuous day-to-day activities. And this is a big challenge. And standardization, as you have mentioned, could play a key role if we follow it for the faster deployment in that sense. However, there are concerns, like as you have mentioned, if we can go for a fleet mode for deployment of reactors, and we need the industry to be very much matured to take care of these challenges, and how we can actually go for it, and or if it is 10 reactors only, or we can go for say 100 reactors in fleet mode,
Yes.
whatever. So what are the challenges we have, and that sort of scenario we have? I would like to invite Mr. Pillai here, who has been associated with nuclear industry for long, as I know Walchand Nagar has been one of the great partner of Indian nuclear industry program. So, Mr. Pillai, your thoughts on this topic and on these challenges, please. Thank you, sir.
Am I audible? Is it?
Yes, sir. You are nicely audible. Thank you.
Okay. Good afternoon, everybody, and the chief guest for today's program, Dr. Barua, Dr. Malhotra, Dr. Ojha, Dr. Deshmukh, Dr. Rajiv Singh, and obviously Dr. Nitinder Singh. Good afternoon. The topic of today's discussion is a very interesting thing. I am not going to talk on that much, but it's important in the sense that, first of all, for the shortage of time, I will try to cover my talk in the three aspects what we are going to discuss about energy security, about the need for imports, why do we still import, the requirement of calibration or measurement, how it can help India, achieve greater heights. Okay. Now, if you really look at it, India as a country today is on the threshold of being one of the world's major power. When I'm saying major power, it is in terms of economy, in terms of defense, in terms of healthcare, and even in terms of statesmanship. So the country today is poised to really lead the world. That's no doubt. We are all very happy what is happening in the country, and we feel that yes, we are as citizens of this great nation, we should be proud of our present leadership and the way they are trying to take things to the next level. Now, at the same time, but for a country like India to reach its destination of global superpower, one of the most important aspects is energy security. Okay. Now, let me quote somebody. I am not quoting any foreign, leader or foreign people. I would like to quote our own homegrown, one of the most finest technocrat, researcher, scientist, and human being, Dr. Anil Kakodkar. I had the privilege of working with him very closely as he was on the board of my company when I was the MD and CEO. Dr. Kakodkar says energy being a key factor for meeting human needs. I repeat, energy being a key factor for meeting human needs is also a significant multiplier of the human capability. Beautiful words it is. People look at energy only as energy, but with energy, apart from meeting the human need, it also is a multiplier of human capability. Now, it's very, very pertinent, very important, particularly in today's context, that when we are discussing about energy security, this particular statement of Dr. Kakodkar is really making a lot of sense. Now, why are we not talking about energy security even at this stage in 2021? I will come to that, but just for a point, I find that the organizers, as well as many of the speakers, have got a nuclear connection, and many of the discussions are with regard to the nuclear. When Dr. Nitinder introduced me, I did not give him that information. I have a very deep connection with the nuclear, not my association with Walter Nagar or a Heavy Engineering Corporation or Instrumentation Limited. All these three companies had deep association with the nuclear power generation of India. But many may not know that my first job, I was in the training school of the 17th batch. I attended the training school of PRC of the 17th batch. So as I said, the DNA of mine is also nuclear. Anyway, that was just a small information I thought. Okay. Now the ability of a nation to secure sufficient, affordable, and consistent energy, as told by Rajiv Singh, is very important. Then only that nation can really come up. Now, there is this International Energy Agency based in Paris. I am sure Dr. Nitin will be knowing very well about that. It was set up in 1974 to bringing certain policies and help various countries to meet the energy requirements of various countries all over the world. In the latest report of IEA of India 2020, that's the latest report, just a couple of months back, Dr. Faith Byrol, the executive director, talks. If you read that report, you will feel elated that the way the country, this country about 10 years back, or at the Pokhran blast, after the Pokhran blast, you can imagine how India was treated both by the Canadians and the Americans, and how today India is looked upon by the world. And if I quote this IEA, he talks beautifully in his statement he makes in the executive summary. He says, India, the present leadership of the country, has brought power to more than 700 million people since 2000. Emphasis on deployment of renewable energy, mainly solar. Incandescent light, bulbs replaced by LEDs, the government's Ujala scheme. 80 million householders given LPG for cooking. Now, people may look at it in the political way. No, if you and me look at it in the real technological way, forget the politics, technological way, those ladies who are actually, all the smoke was going into that, carbon, it also helps in reducing the carbon emission. So that 80 million households are given the LPG connections. Most important, energy pricing norms. That's very, very important for a country to develop and become self-sufficient in energy. Pricing norms for coal, gas, electricity, which are fundamental to the further sectors of opening up of the energy security. Energy security is also enhanced and not only restricting to the power or a nuclear or a thermal power, and by help, that is hydrocarbon exploration and licensing policy of the government. The government is really looking ahead, the help and building. Many of you may be aware, building a dedicated oil emergency stock in the form of strategic petroleum reserve, which the country today has got. Now, these are some of the areas which the government has actually taken. We may look at only whether the power is coming or not, but the people behind, the people who are looking into that, the government, the bureaucracy, the executives, the organizations like BERC, they are all going into depth looking at India's energy security. India's energy consumption is growing at a CAGR of 6% during the last decade. And this demand curve, as Dr. Malhotra just now some time back mentioned, the demand curve will rise further with universal electrification of households and also new use of electricity like electrical vehicles, because tomorrow it will become a mainly a electrical vehicle population, if not in 5 years, 10 years, but the way Tesla is going, and Tesla is also planning to come in a country like India, I am sure. So the demand for electricity is going to increase. So that is one part. The next important point, which is very, very important here, for India to become, again, my introduction is about India, how India is going to become global superpower. The next important point is our population. We have a population of more than 50% of the India's population is below 25 years. Other day, somebody was telling me there are only 8% of India's population above 60 years. I mean, this is something of a huge benefit to the country for the country's progress. If you look at a country like Japan or many of the countries in the European countries, I think the majority of the population is only in the older segment, which is definitely not good for the future of the country. So India has that particular big advantage that yes, the population is there, technological knowledge is there, the expertise which is available in various educational institutions within the country is very good. And to add to all this, the message what the Prime Minister gave about Atmanirbhar Bharat. Now, Atmanirbhar Bharat, as Dr. Malhotra did mention, there are examples of people who have been actually working in the country for many, many years. Let me give you a very interesting example. Many of you may not be aware. People are aware that there's a company called HAL, Hindustan Aeronautics Limited. Many may not know that HAL was actually set up by the Walton Group in 1942. In 1942, it was known as Hindustan Aircraft Limited. It was a total 100% Walton company. So even at that time, India did not have a bicycle manufacturing company, but Seth Walton Hirachan felt that the future of this country is only in high technology, and that is how he actually started this company. And it's a different story, but I'll just take half a second or 10 seconds for that. It became HAL because during the Second World War, the Japanese had attacked Burma, and the next target for them was to come to India. The British government told Walton Hirachan that in case the Japanese come into India, you should demolish this factory. We don't want to give to the enemy a factory of manufacturing of aircraft and runway on a platter. Walton said, what? He said, my job is to construct. I will not destruct this. This is what he said. And at that, the British government took over that company. Anyway, that's not the main topic. What I meant was Make in India, Atmanirbhar Bharat, which did start at various places. But now with the Prime Minister's focus on Atmanirbhar Bharat, this is the time for us to really look, why are we importing? If we have to become energy secure company, why should we import the things? Why not? Can import be stopped overnight? The answer is no. We have to be practical. But that mindset should be there that yes, let us stop import, let us start manufacturing in India. And that is a very, very important point. I will also just speak on terms of nuclear because Dr. Malhotra did mention a very important point about the base load. Actually, the government of India, in its Paris climate change conference in 2015, India committed to increase the share of non-fossil fuels from 30% to 40%. And we are working towards that. The government of India plans to install 175 gigawatt of renewable power by 2022, raising from the present 70.6 gigawatt to, mainly which is in the wind sector. Now, this will require sufficient base load. As many of you are aware, this base load is not available through any other means. It can be done through thermal power, but then again you are going back on a commitment to the globe. You are going back on a commitment to the future generations of our own population that we will avoid extra global warming. So there it comes the requirement of nuclear. How nuclear, and Dr. Malhotra very beautifully explained that it is not a competing with coal or nuclear. Nuclear is needed as the base. Today, the nuclear power is only 2% of the total India's installed power generation capacity. It's only 2%. And as we all know, from the present 6.7 gigawatt, we are going to 63 gigawatt by 2032, and we should give credit, we should salute the Prime Minister for first time coming out and allowing 10 important reactors, 10 nuclear power plants of 700 megawatt, the PHWR, at one stroke. And this answers the second part of the question, as again Mr. Malhotra did mention, that it's a standardization. One plant of 700 megawatt used to take 6 to 8 years, sometimes 9 years for setting up. Now, this is the one of the bane for us. The project management has to become perhaps very, very important. I'm not going into the detail why, how, there's no time for that, but it is important. And this 10 projects of identical 700 PHWR, a classic case of Atmanirbhar Bharat, Make in India, totally dependent on the local manufacturers. And we can all be proud, we Indians can be proud. All these power plants which is functioning in India have been functioning very well without a single incident of malfunction or accident. So credit should go to the Department of Atomic Energy, to all the scientists, all the engineers, and the manufacturers also, because ultimately it is they who manufacture equipment of the highest order. So this is one part. Now, so renewable energy, we need this base load. Nuclear is the only solution. Initial capital cost may be high, no doubt about that. But with these type of things, what the country is doing, that is identical plant, the cost of engineering goes down, cost of design goes down, cost of manufacturing goes down, cost of inspection goes down. It becomes a very standard product. I was giving a talk the other day. Somebody said, what is this standardization? How does it reduce cost? If you really look at it, in India, about 20 years back, people were never buying ready-made pant or shirt. We used to buy cloth, go to a tailor, he makes it into to your measurement, and that is how everybody used to feel happy. But today, you can't even get it. You get only ready-made, because the moment you become standardized, the moment you make some systematic approach, whether it's a 40, 41, 42, 44, whatever it is, the productivity increase, the cost of operation comes down, the profitability increase, and no tailor loses job, huh? because they get jobs somewhere else. So, an important point. So, this was my initial background, which I thought today India is at the verge of becoming a global power, and for that, energy security is most important. I'm not repeating many of the things because Dr. Malhotra did mention. What my next point would be, why do we import? Do we need to import? Can we stop import? That was one. And third one, I'll come back to the measurement and other points. Now, as I said, do we need to import? The answer will be mixed. If somebody says nothing has to be imported, I think that's not the right thing. Okay, at least we'll have to import technology. If not the manufacture, the technology is needed. If we today manufacture a item which is quite behind in technology, it's of no use. We should have the latest technology, and perhaps that is one of the reasons why we are talking to a ED of France or Westinghouse to get into the new latest technology, because the technology is the only driver for the growth for any country. So it is important. So as I said, import will be needed. It should be calculated import, but what all can be manufactured within the country, perhaps we have to do that. Now, another area where import will be needed is in terms of materials. Let us be very honest, because these type of industries, the requirement of very specialized material is there in not very large quantity. So there are very few manufacturers in the world who have actually really done a lot of work into it. I'm not saying India cannot do that. I'm very proud to say, perhaps many of you may not be aware, HEC, Heavy Engineering Corporation, which is in Ranchi, where I had the privilege of being the chairman and MD, during my time, we built the most specialized forging used for nuclear submarines. Now, that is, India became the 5th country, and it was made in a public sector Heavy Engineering Corporation, Ranchi. So we can do that, but still getting material, getting the most critical material from locally is a challenge, but that challenge has to be overcome. We'll have to do that. Another point which comes is, why do we import? I think it is a mindset. Let me give you one simple example. Even today, when you look at, you want to put up a steel plant, you still import certain technologies from all over the world. But hats off to two areas, nuclear and the space. The ISRO, Indian Space Research Organization, and the BRC, Bhabha Atomic Research Center. These are two areas where 100% indigenous manufacturing, indigenous design is available. All the launches, whether it's the Chandrayaan, whether it's the Gaganyaan, whether it's a human space shuttle, which we are going to do that. Let me be very clear. All of you are aware that it is 100% indigenously designed, indigenously manufactured, indigenously calibrated, and it has been successful. Our space program is today perhaps the best space program in the world. Even NASA looks up to India, what India is doing. So, what is the message? If there is an intent, you can do everything indigenously. Why we did it? Because after the Pokhran blast, both in the nuclear segment as well as in the space segment, there has been embargo on it. We were forced to do that. Look at the present vaccine which is happening in India. Why it happened? Because we Indians are capable. Otherwise, had it been some years back, if our morale would not have been so good, we would have waited for some vaccine to come either from Russia or from Europe or from America and pay a huge price. Today, as Indians, we can be proud that we have the wherewithal, we have the knowledge, we have the research facilities for doing things in India. So I just brought the vaccine point to give a weight to India's capability. So what is important is the mindset of the leaders. That's very important. Of the leaders. We are all followers. If the leader has a vision that it should be Atmanirbhar Bharat, you and me will go out of the way to make it Atmanirbhar Bharat, because we take pride in what we have to really, what we can do in our country. So that is one point. Now, it's not from the manufacturing point of view. Let me, if we have to really remove import, there are certain things which we'll have to do. A speech by the leadership, by people will not suffice. We need some changes in actually implementation in the ground root, in the grassroots for the manufacturing sector. Let me tell you from the manufacturing sector only the next couple of minutes. Now, what is the one point? The limitations in meeting the international standards. One is the measurement and calibration equipment. You see, that is very, very important. you know, the measurement is as accurate as the instrument, nothing else. If the instrument is not accurate, you can't measure it. So perhaps that is the first part. The second part, I am always a strong proponent that MSMEs, the small scale industries, medium scale industries, perhaps they have to play a very important role if we have to raise the quality. A company like a BHL or a L&T or a Walchand or a Godrej, they may improve their manufacturing setup very well and bring in the highest quality of equipment, machines, etc. That is not sufficient. The small scale sub vendors for these large companies, their level of has to really enhance. Today, many of the small scale industries, the subcontractors think they have to just make something and give it. I think that attitude should change. The large companies should support the subcontractors, MSMEs, improve their manufacturing facilities, bringing better machines, improve the quality standards in those subcontractors' work, then only the final end product will be very good or meeting the quality. Otherwise, what happens today, what is the mentality, perhaps many of you may not know. You get 100 items from a subcontractor, 70 passes, 30 gets rejected. So only the past one is taken for the manufacturer. That is not the right thing. The right thing, if I get 100 should pass. And so my point is, the quality standards, the measurement standards, the overall mindset of the subcontractors, of the MSMEs and the manufacturers have to be in unison with global standards. Then only we can make a product which is as good as anywhere else in the world, and then only we'll be able to export the same. So these are some of the points with regard to the manufacturing, industry. Dr. Malhotra did mention about, is the Indian industry ready if there are, these 10 new nuclear plants coming? So similarly, there are other areas also. You look at the defense sector today. The government of India in the first list has 110 items has been put in the only domestic manufacturing sector. The import of those 110 items are banned today. Okay. Now, I'm fortunate enough to work even in the defense sector. I can tell you one thing, the Indian industry today is charged, very well charged. Indian industry today is capable of meeting the requirements either of the nuclear power or of the normal power plant or the defense sector or the space sector. The need of the country today is most important. And as I said, it all depends on how the leadership of the country is able to motivate the people. All the industries unanimously have said, yes, we are with you. We as Indian manufacturers will meet the requirement. So my point, the second point is, the Indian industries are today in a position to meet. We are improving our knowledge base. We are improving one aspect, perhaps I think I should not forget that. One thing which most of the Indian engineering manufacturing industries lack is high technical knowledge in terms of engineering. We give a lot of emphasis on the manufacturing, on the testing. But what is needed is the core engineering importance to be given to engineering, to the manufacturing industry. How it can be manufactured most optimally, operationally, best method. So this is one area which many companies, like my company, Walchand Industries, is putting a lot of emphasis in improving the engineering skill. We call it methods engineering or manufacturing engineering. Those skills have to be improved so that we can, manufacture at an optimum cost. Last point, I'm not taking much time. I know time is already late. The last point is with regard to the measurement or calibration. Now, whether it's if energy, we all know, for example, the energy meter, I'm going back, long back. If I am producing 100 megawatts of power, is 100 megawatts being used apart from the transmission loss, etc. But there are other losses because of the measurement and instruments. I happen to be working in a company called Instrumentation Limited. So I am very much aware about the role of instrumentation. When I started my career in 1973, instrumentation was supposed to be relegated to somewhere in the corner. But today, if you look at it in 2021, instrumentation, measurement, control is perhaps today one of the most critical areas of any process industry, any power plant, any nuclear plant. Why? Because it helps one to reduce the overall quality. Sorry, to reduce the overall cost. Two, it improves the overall quality. Third, it gives you sustainable output. It is not sufficient that I get today an output so good and the very next, after 24 hours, the output goes down. So it gives sustainable output. So the role and challenge of the instrumentation industry is phenomenal today. Today, instrumentation industry has gone to such an extent that, with smart equipment, smart positioner, smart transmitter, that you can even predict what is the shape of damage which has happened to a control valve, which is most critical in any of the plant, be it nuclear plant or be it any refinery or petrochemical. So I am very happy that Indian Youth Nuclear Society has taken up this point. This is a very large, aspect of discussion. But as today we have a limited time, the only point which I want to emphasize today that a small item like measurement, control, and standardization is very, very crucial for the company's growth, for the country's growth. And somebody did mention that I think Dr. Nitin only, had mentioned. There are three aspects. One is money. The first aspect is money is needed for. And when you have, money is always limited. People can't say it's unlimited. Okay, it's always limited. But if there is a limited money is available, it is in you and me, the technocrats, the engineers, the scientists, to see to it how we optimally use this money for the larger benefit of the industry and the country. So, thank you very much. I would like to thank the Indian Youth Nuclear Society and also would like to thank the Fulton Educational Society for arranging this program, inviting me to talk to all of you and talk to the youngsters. And if youngsters who are listening to this talk, I want to leave one message to all the young students or the young executives or the young engineers. I just mentioned in the beginning of my talk, India is to become a global superpower. People like me or many of the panelists will be only able to do a little bit towards that. It is you, the youngsters, who would actually steer this country to make it. It's not sufficient to only make it. We may make it. You have to actually see to it that it is sustained and India becomes a global power and remains a global power. Because if we really fall down, you can see what is the condition of Europe. There is no Britain, there is no UK, even France is in a different position. All the Europe is out. Russia is out. I'm sure many of us remember in the initial stage, Russia used to be one of the strongest country in the world. So if India has to become strong, India has to be a global superpower, we will make it. But youngsters who are listening to this talk, it is your responsibility to see to it that India remains a global superpower and within the framework of humanity, society, and the further population should be able to live very well. Thank you very much. This is my initial submission. Thank you.
Thank you so much for this enlightening words, and I think you have rightly mentioned, and you reminded me of our own Mahatma Gandhi and also Einstein mentioned these two of the great people mentioned in their own words that winning is not the important thing, but maintaining that win is really important. And you have rightly highlighted that our youngsters and youth of our nation has to take this responsibility and continue with this. And you have also highlighted few key aspects which I would like to mention again, like the development of MSMEs, the medium, small, and small enterprises is really needed to actually maintain this sustainable development and grow, because as you have rightly mentioned, the big industries can of course make the big components and can uh, assist any energy industry or any big industry in the country. But however, we need to have, there are n number of small components which are required to be utilized in all that sort of industry. If we are importing them, for example, then there is no use even of developing the big industries in our country. So yes, of course, these sort of vocal for local is also needed. So here I would like to invite Dr. Oja, who has been working in this area for long. He has been associated with NPL Delhi, and he's working in the area of standardization and how we can maintain the traceability. The one of the challenge which Mr. Pillai has mentioned, like how we can maintain the traceability of calibration or the measurements which should be of standard. When we say standard means what is the most accurate thing which we talk about. So all these reference material and stuff he's been working for long. So Dr. Oja, over to you. What are your thoughts in this concern, and how you see or how you perceive this situation of energy security, sustainable development, and the role of measurements altogether in this scenario? Thank you, sir.
Thank you, Dr. Nitin. It's really my pleasure to be a part of this august panelist who are really pioneer in their own areas. I am just a beginner to learn I understand about the measurement science. This measurement science, basically, we can also put in the word of ISO vocabulary that is called metrology, the science of measurements and its application. So for the young generation who are listening as a participants here, I would like to emphasize one important thing, that whatever is said by our panelists, Dr. Pillai, Dr. Malhotra, Dr. Nitendra, they have already highlighted what the importance of calibration and standardization in one way or the another way. So here what I would like to do is that I little bit try to little bit brush up and bring you to the background also, that why it's so important. And as Dr. Nitendra pointed out, that if we do a measurement and we say that this measurement, how accurate it is, then it has to be traceable to the system called SI unit, that is International System of Unit. Here I would like to point out what Dr. Pillai has already pointed out about the short definition he gave. Now the question arises, if you are talking of 40, 41, 42, similarly you can take another example while you are drinking, say, cold drinks, or you are taking some bottles of, say, water, and all these things. There are two aspects which are becomes important to understand here. Suppose if I have a bottle of water which is containing 500 ml, then how much the value of 500 plus minus is there, that we call uncertainty, and that is to be understood. That can be done only by measurement. But also simultaneously we should understand that this 500 ml bottle, in what bottle it is kept, what is the purity of the water which is contained, or the mineral contained in that, there becomes a agreement between certain standards which is required, so that it becomes a potable water. Then we say it is a standardization. So this is a very simple example just to give to all of you that what we mean by this. Now this calibration part which we were talking basically starts in reference to some other standard. Suppose if I have to calibrate this water bottle of 500 ml, then I should have certain standard, which is a 500 ml capacity, and then I measure to it. Now, if I measure this, and if it is some uncertainty or accuracy data we can know, then we can say, okay, this is plus minus 10 ml, which is missing here, or 5 ml, which is missing here. Then you can understand that. And that is where it is important to understand that whenever you purchase any item, it may be a grocery item, or it may be any food or drugs, say pharmaceutical items, all these are marked by certain values. That, okay, if I take a pill, this is the component of the pill. This pill contains so much of particular molecule, and this is in microgram. Now, if this is in a microgram, and if we don't know the value or accurate value, then what will happen? This pill itself can become a dangerous. If it is over quantities there of the microgram of particular X component, then what will happen? This will be a dangerous, hazardous to the health if I take that pill. Or if this pill contain that particular X molecule lesser, then what will happen? It will not give an effect to your body. It will not help you out to fight that. So what is important to understand here is that this is the calibration. And now to have understanding of calibration to be accurate and reliable. That's why calibrations are important in industries in day-to-day life, because it gives you a reliability of your measurement, a reliability of the product, the quality of the product, and the consistency in the product. This is what Dr. Pillai indirectly means. So basically, calibration gives three aspects to you. One is that it gives you understanding that whatever you are doing is reliable or not. It is consistent all the time or not. And this can only be achieved if it is traceable to the international system of unit. And here I'll just like to little bit brush up and indicate to you that there are 7 base units, which most of the students, young people, they must have read in their 9th, 10th class. Now here I would again like to add one more thing here, that this 7 base unit recently have been redefined. Now we have a redefined 7 base unit, which started from 20th May 2019. All over the world, May 20th, 2019, everyone will be following the new definition of SI units. So all these 7 base units are redefined now. And out of them, the mass, which was a prototype earlier, has now been replaced by the Planck constant. So all these 7 base unit has now become as a fundamental physical constants. So that is interesting to understand here. Day by day, technology is improving. And for this improvement, you need better and better system so that you can measure them accurately, properly, consistently. You can measure them. For that, you need, it has not to be based on the artifacts. Like in earlier days, your length was based on an artifact of a meter. Your kilogram was like again an artifact which was made. Now slowly all these has been replaced by the fundamental constants. So now in this new definition, out of the 7 base unit, 4 has been redefined. So temperature has been redefined from Kelvin to the Boltzmann constant. So it becomes again a fundamental constant. Kilogram, instead of an artifact, it has become a Planck's constant. In terms of Planck's constant, it has been realized. Similarly, your ampere was again an artifact. It used to be measured, but it was no doubt a quantum metrological based system. It was measured, but however, it has now been replaced in terms of elementary charge of the electron. So you see that how the things are changing, and this is basically going to help in future also if we want to improve day by day. Like for example, I can say you a simple example, like recently you must have heard of Map My India and the ISRO. They have come together. Synergy is there. Now, if Map My India and ISRO, if they want to pinpoint the navigation and the position, then what is important for them is the time signal. Now, this time signal Fortunately, I was ahead of the division when in NPL, when we gave this, the MOU between ISRO and NPL was done, this time signal. And now we are fourth in the world where we have our uncertainty or accuracy of 2.8 nanosecond for this time signal. So now we can precisely and pinpoint the navigation which is done by the ISRO satellite, because these satellites, they use time signal, they have their own atomic clocks, and these are synchronized through NPL, and these are synchronized again at international level. So this is point to be understood here, that what Dr. Pillai and Dr. Malhotra was emphasizing, that day by day we have to become a global leader. So we are already on that path. I feel happy that our generation, whatever we have done, we have already led a path where we are going to this. Now, what Dr. Pillai was saying, I also support him and say that the young generation has to now carry forward what Nitendra was saying. Is not a winning now. It's a question, you have to sustain it, you have to run it and do it. So this is what is now required. So now again, I come back. Now, similarly, what is happening here, one should understand that calibration, and if we are talking of standardization, why it is important for the industry in India also. Because India is now developing, and is developing much faster as was expected earlier, that okay, manufacturing units may not be as compatible or as compatible to Chinese or competitive to Chinese and other. But no, what I am feeling now is that we are slowly reaching to that age. It may be in some pockets only initially, but later on it will improve. Like, for example, Dr. Malhotra also pointed out, and Dr. Pillai also pointed out, that China is producing 80% of the photovoltaic solar cells and the panels, and we are importing them. But what is important here, even if we are importing, and if they are not as per the specification which we have asked for, then what will happen? These panels deteriorates. Instead of working for say 25 years, they are not sustainable to 25 years, and they are deteriorating. So to some extent, we are also equally responsible. Why? Because if we are not able to do their measurement and testing and reject them at the initial stage only, and for that also it is required that our laboratories, our industries, they should be basically geared up themselves, that they should have all the test facilities and they should have all the calibration facilities required for this particular sector. So similarly, in other sector, if we go and see, then again the health sector. So you see, the sustainability word was basically not meant for only energy. It was meant for energy, it was meant for health. In large, I will say it should be meant for all the areas, in each and every area, like climate area also. Now here I'd like to give a few examples for say health sector. Now in health sector, again, what is stopping us is that we are buying instruments from abroad, most sophisticated instrument, and as Dr. Pillai said, we should develop our own system here to develop those. No doubt it will take some time, but even if we are buying outside, and if we are not able to calibrate them and test them properly, we cannot reject them, because one of the technical barrier to the trade, according to WTO, is this technical barrier to the trade is that you have to prove that this, what you are importing or exporting, meets the certain qualification. For that, you need testing and calibration systems in India. And here I would like to point out that NPL is the National Measurement Institute also of India. Like all over the world, we have one national labs in each country, like NIST, National Institute of Science and Technology, USA, NMIJ, Japan, in Australia, CSIO, in NPL, UK. They all have lab. Similarly, NPL India also have National Physical Laboratory. And through Gadget, they are maintaining all the 7 units, and they are responsible for that, and they are disseminating that system. So we are already geared up, and whatever is required, we are slowly gearing up to that. So my young generation who are working in the lab now, they are already developing whatever the requirement. Now you will see day by day new requirements, new testing facilities, new calibration facilities will be required by all of us. Now, for example, Internet of Things. It is a very simple thing. Now you say that Internet of Things, everything is connected. You can, with your mobile, you can connect everything. Very good. And what is the crux of all this connection? The time signal. Now, even if you don't have this time stamping properly, you cannot control one instrument by another instrument with the same mobile. and India is already geared up with 2.8. So, okay. So any industries who are interested now to develop this Internet of Things based instruments, we are ready in that way. We can support them. Okay, so this support can also be done by MSME. Also, MSME can, as Dr. Pillai was asking of that MSME, the MSME can take up small projects, small industrial projects, and they can grow. And for them, NPL is there, and also accreditation bodies are there who can provide them the calibration and testing certificates to them. So that once they have the certificate, so what will happen, they will have the quality product, and these quality product can be easily distributed or maybe sold in the Indian market. They can also be exported because they can compete at international level once their quality and this are. So all the manufacturing units, it is important for them if to have a quality structures with them, that what is required from the quality point of view, that they should have a proper calibration in-house, as well as if they cannot maintain in-house, they can make use of NPL or they can make use of any accreditation bodies. So overall, if I put in a nutshell, India for long is already in a very good position in testing and calibration in one way, because for quality infrastructure in India, you need four pillars. For any country to have a very good quality infrastructure, you need a four pillars. Those four pillars should have a synergy among themselves. And these four pillars are National Measurement Institute. So India, we already have a National Physical Laboratory, which is a National Measurement Institute. Then you should have for standardization, Bureau of Indian Standards. So we already have a Bureau of Indian Standards, which are giving ISI mark and other product. Also, then you have for basically some legal issues like weights and measure department. So Department of Legal Metrology is also there. So if there's any problem regarding say standards and health hazard problem, or if any legal issues and weights and measurements are coming, legal department is already looking into it. Then you have a Quality Council of India. Under its gambit, you have a different organizations, and one of them is your NABL, National Accreditation for Testing and Calibration Laboratory, NABL. So they are giving accreditation body. So in the like India, country is a vast country. In this country alone, NPL cannot suffice or cannot help each and everyone all together at the time. So what will happen? You have these accredited laboratories which are traceable to NPL, and NPL is traceable to the is directly related to SI unit through a international intercomparison. So all the certificates which are issued by NPL are internationally accepted. So after that, any accreditation laboratory, they will automatically become traceable to NPL once they are accredited. So they can provide services to the local industries, and in that way, the industries will grow and they will have a quality product, and ultimately they will reach to such a height that what Dr. Pillai, Dr. Malhotra, and all of us are wishing, that India should become a global leader and Atmanirbhar Bharat. With these some simple arguments and suggestions and advice to my young generations, I will say that India is no doubt is ready. And from my point of view, we are sustainable. Even for climate, if you like to add before I wind up, I can say in climate area also, what is happening, we are buying the measurement instrument like BEM, beta attenuation methods are used for measurement of pollutions like PM 2.5, PM 10. And we find that they are being imported, and their import calibration and testing is done at their country where their climate is different than what the real climate in India is. So we need our own system for calibration, and India is already gearing to that. Industries are coming up to make the measurement system, and to provide them the traceability and calibration, NPL has already started the systems which is called your online continuous air quality measurement system. And also we are planning for this emission measurement system. These are required, OCM and CAMS, which are required. And for that, India NPL has already got funds from the Ministry of Environment, and also they have given us a chance that NPL for the first time has become also the certification body in these areas. And this has come as a gazette. In the Gazette of August 2019, it has been said that NPL can provide these certificates. So now you see, for the Atmanirbhar, for development, we are already there. So NPL, I will say it's already working, and we need a synergy of all the other four infrastructures group. Also, we need synergy from the education sector also, because ultimately all the basic concepts and philosophy of the idea or science also comes from the young mind, and these young minds are developed in different universities and engineering sectors, so their education also becomes a very important role in this area. And also the industry also become important, also plays an important role in two ways from my point of view. One is that they should take help of all these calibration testing facilities to develop their quality. And second, also some money they should pump into this system, because all this system at present are funded by the government. And one should understand that everything funded by the government has certain limitation. It cannot grow like that. So for that also you need faster for the country to grow, because one should not rely only on one side or other side. If you have to be have a cohesion. If you see, the good networking plays a very important role. And one of the example what I have seen is in Japan. If you see how networking systems they have, and this networking system has really grown them in few years. Similarly, Korea also, if you see in 25 years how much they have developed. So there are two, three things. One is the networking, proper dedication. And again, it reminds back me to Dr. Nitendra before I wind up the three: time, energy, and money. Okay, thank you very much for giving me an opportunity. I feel privileged, and thank you very much once again.
Thank you, sir. Thank you so much. You have actually highlighted the key areas, and you have actually networked all three components which we have discussed. And this discussion has been fruitful so far. And what I have understood briefly out of this is like we all know that we are living in the climate emergency, and if we take that thing, and India has done so, I would say like really nice to fight against that climate change, and its policies and everything are very well in line with that agreement which we signed in COP21 in 2015. Whether it's the energy security, India has very much committed to all this clean energy and nuclear energy, including all solar, renew, everything, including the recent development in ISA, the International Solar Alliance, or all these policies are very much in line in that aspect. Whether it's the policy of electrification of the transportation, even including electric vehicle policy, removal of diesel vehicles, and all sort of. Along with that, we are also very much committed. Like India is also very much committed to have all sort of policies towards health improvement of healthcare, but all that sort of thing we need to have the energy security. So that aspect is really in line. To do so, we need to have competency in our country, which we have. Like during the discussion, we have found we have a good competency in terms of everything. We feel like uh, as Dr. Ojha has highlighted, we have the competencies in standardization as well. We are having the competency in measurements and calibration as well. And you have rightly mentioned, like if industry and this certification um, bodies and the NPL can come together, this can be very much improved, and this will um, uh, enhance the rate of deployment of all these energy power plants, whether it's nuclear or any other renewable energy, as highlighted by Mr. Malhotra. So we have competency, we have the standardization and all sort of competency. We have the industry readiness, if I understand, as Mr. Pillai have mentioned, everything we have. But still, I feel why are we still slow, or we are lagging somewhere? This is one of the question which we received from one of the participants. So he is asking like, why are still we slow, or we are not able to catch that pace which we are expecting. As Mr. Malhotra has also mentioned, we if we take the example of energy requirement, we need to grow threefold or fourfold to achieve that sort of requirement. Where are we lagging? So this is one of the question, and the question is open to panel. So if you would like to take this question. So Malhotra sir, your smile seems please go ahead. Thank you, sir. You are on mute, sir. Please.
Yes. So actually, this answer, in fact, indirectly, Dr. Nitendra, you have provided right in the beginning. Okay, if you recollect, right at the beginning of today's event, you mentioned something which your father told you. Okay, money. So now I will give you an example. I'll give from my own sector. You know, everybody knows that government has announced or given clearance for 10 PHWRs of 700 megawatt each in fleet mode. Okay, but the money has not come in fleet mode. Only the permission has come. So now when I put an order in fleet mode to Walchand Nagar Industries, I need to tell them that, okay, see, you have to make 10 calendar years, or you have to make 10 certain things for these 10 reactors. Okay, we will award five of them to you. 5 we want to give to somebody else. I need to commit money to them. But so unfortunately, the money has not come in fleet mode. We have to manage our finances. We have to see how much NPCIL can generate its own fund, how much getting government funding for these projects nowadays has become very difficult. So from where we have to borrow. I think that money management is one part. Second is, which is again, I think may not apply in this case, because 700 megawatt is already cleared by AERB as a general design. But of course, site-specific approvals again need to be taken. That is again a 3-tier system. A very important factor, I think, a bigger bottleneck than money. Money we can, if the government gives, well and good. If we can generate our own funds, still better. If somebody can lend to us, good. So there are many ways of managing money. But when it comes to land, there is only one way. If I want to construct a plant somewhere, that land has to be given to me. And it's not that if he is not giving, somebody else will give me that land. Land, if at a given geographical position we want to build a plant, and in India, I think with the present day situation of land acquiring land, the laws have been changed. It has become a major bottleneck. Other day, I was listening to Dr. Anil Kakotkar, and I am very happy that, like me, Dr. Pillai is also one of his fans. I am an ardent fan of Dr. Kakotkar, and I have had the good fortune to directly work under him day-to-day basis. I mean, he was for 10 years, I was reporting every day to him when he was chairman, and I was sitting just a floor below. So Dr. Kakotkar the other day had mentioned in his talk that getting fresh land, getting green land, as we call it, getting green land for a project is becoming very difficult, and at certain given locations, practically impossible. So what he has suggested that if you look at many thermal power plants, big complexes, in India, some of them have become very old. Some of them are being dismantled, will be dismantled in near future. So the proposition is that if those plants can be, there is a confusion amongst the public. There is nothing like co-location. It is a relocation or reallocation. So whatever site was, for example, for a coal-based plant, and now because the plant became very old, so it has been dismantled. So that piece of land, because it is already in the possession of most probably a PSU. So from PSU to another PSU probably may not be very difficult. So we are nowadays, in fact, our eyes are on these lands where some government land can be handed over. So I think that will solve one of the bottlenecks. So I think I have listed money and land. I think human resource, many times people list human resource, but I don't think for a country like India, with so many educational institutes, be it engineering colleges, medical colleges, science colleges, and with the policy of departure, we are not looking for industry-ready graduates. We are only looking for graduates, whether it is engineering or whether it is science. In case of science, we are looking for postgraduates, and in case of engineering, we are looking for graduates. We are not looking for industry-ready graduates or postgraduates. We are looking for just the graduates and the postgraduates. We have the training school, which is now, I think, more than 60 years old. Okay, my 44 years plus 20. So yes, it is 64 years old. Like Dr. Pillai, again, very proud of my training school. And I think that is why with great confidence I say that just give us the graduates, we will make them industry ready at our training schools. Of course, now we have 5 of them. So I think HR is not a constraint to us. So I think majorly the constraint is land and money. Yes, Pelesa.
Yes, sir. Please go ahead.
Yeah, I have what Dr. Malhotra mentioned about land. I think the question what this gentleman who has asked, it's a very, very valid point, which even I ask, or even you may be asking your own self, that if, say, for example, a bridge is being constructed, a flyover is being constructed, they say the flyover will be ready in 10 months. It doesn't get ready in 3 years. Okay. Yes. So, we as a normal citizen find, don't you have the knowledge of the flyover? We have. Don't you know the design? We have. Have you not finalized the contractor? We have. But instead of 10 months, it takes 3 years. Okay, it's happened in the country. I'm not saying no.
Happening. It is happening. Even nuclear power plants.
Yeah. So the question what the gentleman who has asked, I would like to really congratulate him. It's a real question, no doubt. I think who is responsible for whatever be the case, whether it's a delay, whether it's a wrong design, it's we only are there. I give a recent example of the recent match when Ajinkya Rahane was the captain in Australia. We won that match. Okay. Ultimately, the people are the same players. Okay. It all depends on how the leader is able to motivate and ask the team to perform. So, have the Indians changed on the last 30, 40 years? No, we are the same Indian. But if the leader is able to motivate people, we know in our own office, if we tell that the deadline today is this Friday, if the job is done on that Friday, we all feel happy. But most of the time it doesn't happen. Excuses come. So I think here is a time where we have who can make that change. One, obviously the leader. Second, it is individuals. We ourselves have to really be responsible for our own actions. And the most important point, what Dr. Nitin. Now, it is a thing we all know that yes, we should have more hygiene into Shauchalaya. But it has not happened. It's the same Indian it is happening now because the leadership is able to motivate and tell the people how the things has to be done. So, if this gentleman who has asked this question is a young man, I would like to congratulate him for that question. And I would like to tell him that it is you youngsters should ensure that you do your bit on time. Then automatically the whole, all pieces will fall into place and the overall output will come up faster. That is just a supplement, I thought.
You have rightly mentioned. In fact, Malhotra sir has given, which is one of the modern hashtag these days, like modern problem requires modern solutions. So it's a nice solution. We can utilize the already the land which is in use of that particular purpose only. So it's a nice thing, and you have also rightly mentioned, sir, like that sort of thing is needed from the youngsters. They need to think out of the box, and we need to change our way of style, way of thinking. Of course, leadership is there in on one hand, but it's the individual responsibility as well. I think Oja sir has rightly mentioned, like uh, if we say, if we want to bring the change, so even if the change is at the institutional level, like as he mentioned, if we start the calibration facility at the industry itself, or within the industrial department, that sort of change we can grow in together.
Just to add on that, what Dr. Ojha mentioned,
Please,
uh,
sir.
I thought I should put it from the industry point. We at Valchandnagar is a small village near Pune, 140 kilometers from Pune. We have our own lab, which is an NABL accredited lab. So what we do is there are many sub vendors in and around, Pune, Valchandnagar, etc. We allow them to utilize our facilities so that they don't, there is a facility which is a NABL approved lab with latest equipment. So small manufacturers can come and utilize our labs. So that is the thing which we have done.
I think that's the way. It's a good beginning, I will say. Yeah, that is the way what is required. It's not a question of big or small now. It's a question of how we network each other, support
Correct.
each other, and
Correct.
and join hands to come up. Because it's
Exactly.
India which we have to bring up. It's not
Correct.
the individual group or individual country, industry or individual man to. I think we should bring all together and then we come up. Thank you.
Right.
Nicely mentioned. And one question is coming from HR point of view only, sir. The person has asked, like, with a limited number of nuclear engineers or nuclear scientists in our country, what will be the job scenario in nuclear in India? I mean, he means like the job scenario in nuclear industry in India. I think he want to highlight one point, like mostly in nuclear industrial jobs are still limited to Department of Atomic Energy only. Not many private industries are much open to it. I think I'll transfer this question to Pillai sir. He has been associated with nuclear industry for long. And we all know the job scenario are there at Department of Atomic Energy. But what are the scenarios in private industry for that sort of nuclear engineers, as he has asked?
Let me answer this question into two parts. I also saw the question in the chat box, and one point is Dr. Malhotra has actually answered his first point, that the Department of Atomic Energy, or they have a very fantastic training school program, as we all know. Fresh graduates in engineering, postgraduates in science are taken there, groomed, taught everything. That's one. But what I have been telling at various forums, now I'll split my answer into two parts. One is, for the requirement of nuclear power plants itself, there'll be a lot of requirement of people, because 10 new plants are going to come. One area where there will be a lot of shortage of manpower is running the plant, operation and maintenance. Today, O&M is technically done by the department itself, NPCL themselves do that. There is a task force which was recently set up by the government of India, where Dr. Kakodkar Saab was the chairman. I happen to be one of the members of the task force. And one of the points which we highlighted there with NPCL will have shortage of quality engineers. Even today, one of the big problems what they face is to allocate engineers for quality control or testing at various manufacturers' place because they have to go all around. With 10 new plants coming up, it will become a huge shortage. So there the point came whether the private sector inspection agencies or inspection groups can take up this job. So this was a point which was discussed with Dr. Kakotskar level. Plus there was Mr. S.K. Jain was there, the present chairman, CMD of NPCL was also there. So that is one area which will really, there will be new job requirements will come. But so the O&M for nuclear power plants can be done by the private sector, or it could be in the public sector. Even a VHL can do that. So that's not the point. But it will not be an NPCL team because NPCL role should be primarily in the design, engineering, and other activities, the core activities. The second one, as more and more manufacturers in India will start manufacturing equipment, there will be need of engineers having nuclear knowledge. One of the most important things in nuclear knowledge for the manufacturing side is, I'm sure Dr. Malhotra and others may be aware, is the requirement of good welders, welding engineers, NDT people. And I can tell you one thing, they are the one which is in shortage. You don't get good welders, can you believe it? You don't get good welders in the country. Now, that is one. Similarly, NDT, that non-destructive test experts, various classifications. Now, that is an area which will be huge demand, And there, institutions like Palton Education, Society, they should really look and come out with what are the areas where there will be job requirements. So these are the two areas. A third point I may like to add here, he talked about nuclear. In space, ISRO. The ISRO, what do people know about ISRO? People know about ISRO, oh, rocket gaya hai upar. They're all thinking that yes, jisne rocket banaya, they think it's only the few people who are making the rocket are involved. No. We all know that the moment you get involved, as Dr. Oja said, the amount of involvement of ISRO with various other agencies to see that there is an overall improvement, knowledge base is improved. So there's a lot of scope for botany graduates, science physics graduates, biology graduates. People think it's only engineers. No. So that ISRO does a very good program. They go to various colleges in the country and give some talks or seminars. I also happen to be, has been invited in a couple of their talks. So the people are getting, otherwise people are not aware what is ISRO's requirement. I'm sure the Indian Nuclear Society does as part of the awareness. There are a lot of programs they do it, going to colleges, explaining to them. So, for the gentleman who asked that question, the demand will be there. You'll have to really look into where you can fit it. Everybody may not be a nuclear engineer, need not be a nuclear engineer. He can be a quality control engineer for the nuclear equipment, which is a very, very crucial area. He can be designer for certain areas. So, this is what my take.
This you have rightly mentioned, and even at the ITER, the fusion reactor facility in France, the one of the major demand coming these days is of quality engineers, because they are bringing so many equipment from so many manufacturers across the globe, and they want to make sure that the quality they are receiving is of their standards. So this you have rightly mentioned, and also these fields of energy or the space or that sort of application or even defense, they are not like field of one particular trade or one particular in industry. All these are multidisciplinary fields, and all of them require multidisciplinary knowledge and interaction. So this you have rightly mentioned. We have received one more question here. Before we conclude the session, we'll take this question. What is the opinion on the nuclear engineering as a subject in the private or non-DAE institution? I think Mr. Malhotra can take this question. The question is, sir, what is the opinion on the nuclear engineering as a subject in private or non-DAE institutions?
Yeah, I have seen this trend that, in fact, some of the universities, after my superannuation, some private, these, particularly the private universities have this tendency for luring the instrument, they are luring the students, they will give some fancy terms, different kind of engineering. So I think some universities approached me after my superannuation that why don't you come and draft a course for nuclear engineering, nuclear science and engineering in our university. What I suggested to them, again I am telling, the nuclear industry as such does not look for industry ready or research ready graduates. We want to have qualified bachelors and graduates and postgraduates. We at Department of Atomic Energy will reorient them into our requirements. We will make some of them into very fine operators. We will make some of them into very fine design engineers. We will make some of them into very fine safety engineers and radiation safety officers. So I think this should be left to us. Definitely, nuclear science and engineering, maybe as a subject, as one of the papers in BTech. If somebody introduces, I have no objection. But offering a bachelor's degree in nuclear science or nuclear engineering, I am particularly against it. Because, see, once you do that, unfortunately, the students will feel that the burden of absorbing all these, the primary burden or responsibility will be of Department of Atomic Energy. And then next will be of people like Pillai sir. Okay, which is not true, as Pillai sir also mentioned, and I also mentioned in my talk. We are not looking for nuclear qualified graduates or postgraduates. So I think good engineers studied various disciplines of engineering, whether it is mechanical, whether it is industrial engineering, whether it is chemical engineering, chemical technology, civil engineering. Everybody is required, I mean, at our department. So particularly from the point of view of absorption in nuclear industry, but one need not be, I am repeating probably next time, one need not be a nuclear engineer. But maybe I think DAE was running a course, specialization MTech programs. They are with specific needs. In certain areas we need. So again, they have to be picked up. Again, a university independently doing an MTech program will not be a good choice. In between, we had an MOU. I don't know what is the situation today, because it is more than 5 years that I have superannuated. So I will not have the fresh knowledge. But when I was there was MOU between India and between DAE and some of the IITs. Kanpur IIT, I know very well that we were running an MTech program where the selection, right from selection of the students, it was responsibility of DAE. We were involved in selection of the students. We were partly responsible in imparting education at Kanpur IIT. And then, yes, there was some sort of, I don't think there is no guarantee, even to, when we join training school, there is no guarantee that we will be absorbed. I mean, there is certain criteria. If we meet that criteria, then only we are absorbed. So I think job guarantee was not given even in MTech program, but there was a very good possibility that such a collaborative program between an academic institute and DAE, with a purpose we run a MTech program, there it is all right. But any university or any institute on its own to lure students for doing MTech or for doing BTech in nuclear science and engineering, I am particularly against it, and I advise the students, the universities, not to pursue this.
Thank you, sir. You have mentioned very nicely like the nuclear, and as I was saying, like nuclear and these all industries are open to all. Like there's no particular restriction of any trade or something. So yes, everyone can be a part of this industry. But I feel the question comes very often to our all the discussions, mainly because the nuclear and space, they are very fascinating subjects, and everyone want to pursue it, and that's how they want to get directed into that sort of discussion. Before closing the session, sir, one final question I have. Like, this is my personal question, I feel. And I know it's a complex question and it cannot have a straight forward answer, but the question is still remains the same. What do you feel like all of you feel we as I mentioned we have everything, but if we want to develop one model, how it should look like to ensure like we follow the all the measurement techniques and standardization, and we develop our industry in such a manner that somehow we reach to this sustainable development goal of the country, for example, in terms of nuclear, sorry, the energy security as a whole. Mainly, I would like to focus here on clean energy, because we all know this is the energy for the future. So if one final comment from all of you I can have on this particular question. It's a complex question, but whatever simple model coming to your mind, if you can share your thoughts.
Yes,
Yeah.
sir.
Yes, sir. Pillai sir, go ahead, please.
Yeah, okay. As you rightly said, there can't be a very straightforward answer that this is the answer. Okay, taken for granted. And we are talking about mainly the clean power. Okay, we are not talking about the fossil power, non-fossil power only. And if I, for the time being, restrict, say, to the nuclear, for example, instead of going to solar or wind, uh, without making it more complex. See, as far as the nuclear power is concerned, as I said, this particular team, which was set up by the government to look into the requirement, rather the question was, do we need nuclear power? That is the first line of the question, okay, of which Dr. Kakodkar, we are all in the committee. It is needed. So ultimately, there is no doubt it is needed. Okay, and then only these 10 nuclear reactors were cleared after this report of what we gave. Now, Dr. Malhotra did mention the shortage of funds. There is no doubt on that. It is our bad fortune that it's a global phenomenon. The COVID, which has actually made an impact, has made a big impact. People may not realize it, but in reality, the funds allocation to various projects of the government has been impacted to a large extent because a lot of effort has to go to the healthcare and agriculture. Because if you really look, two things, healthcare, lot of effort has gone. Similarly, agriculture, because we had never had felt a problem of food grain in this last 1 year of the COVID. Okay, so ultimately it's the government's money. So the government's money, in terms of which was should have been allocated for perhaps this, 10 reactor, is today not available. My take was about in the month of March that the government may even find it difficult to fund projects in the defense sector. My opinion, I still have that opinion. It's a personal opinion that the world has realized that power is not in gun. Okay, America is a strong military power. France is a strong military power. But what happened to them with a virus like thing? It can change the whole complex situation. Okay. So I still feel maybe after some years, people may realize there's no point of spending money on defense, there's no point of fighting with each other. It is better to live in peace. It's an ideal thought, but I still feel it will come. So I was under the impression that defense also the spending will come down. But for our bad luck, the happenings in the border did compel the government to put some money more on the defense requirement, particularly with Atmanirbhar Bharat, the industries have to be really supported. So jobs like, projects which are in the nuclear segment and all has got affected. So that is one reason why we find it has not happened. Had this not happened, because as Mr. Dr. Malhotra also mentioned, these 10 project designs are clear, everything is clear. The manufacturing, they are also already thinking of placing orders on fleet mode. It would have gone in a very smooth manner, at least this 10 project. Whichever is coming, you put one. Another one is coming, put two. So that is one reason why it has impacted. It is not an excuse. I was only trying to put it. But so having said that, I think once the economy comes back on rails, which we think should take at least 1.5 to 2 years, that is what my feeling. I'm not an expert, there will be others economic experts, but I feel it will take at least 1.5 to 2 years, and then there may be a tempo for such projects. This is my view.
Thank you, sir. Dr. Ojha, if you would like to add something to this.
Yeah, basically, I would like to say supplement what Dr. Pillai was saying, but maybe in my own technical style, maybe a little bit, because I am not an industrialist. Uh, the point is that, again, I will emphasize again it back. It's a question of what government really wants to bring. Sometimes what happened, money shortage is there. We all agree. We understand that. This can come, that we also understand. It will take its own time. But what I personally feel, it should be more like a concrete decision which should come up. Means certain area we should pick up. This is just my personal view. Certain area government should pick up where we have all type of expertise, including industrial expertise, also technical expertise. Also, we should have, say, knowledge based expertise, human resource based expertise. We should pick up certain area. Okay, whatever area. It's not a question nuclear, defense, this or that, or energy or this, whatever. Even if suppose energy, solar energy or something, no problem. Now, once you pick up this particular area, then there should be a high level committee involving all type of people, and then they should see that time bound money is also given, and then output is expected, because this output will again refund the source, whatever source was there. Because once you become internationally competent in all this area, because for any industry or any area to develop, the three basic C's which are required is your competence at international level. Are you competent enough? Then you should have a conformity, means whatever product is coming is a quality based product or not. And then the connection at international level where you can supply it and get the resource back, money back. So this is one model which can work, provided it's a commitment, was as everyone accept it. The commitment is must. But with commitment, you should have one particular area, chosen area. I will feel like it's more like an Arjun seeing the eye of a fish. And then you can target it, and he has won. Similarly, we can target one area and we can run at international level and become a pioneer in that. Then what will happen? We can take second area and third area and so on. So money can again generate and can be siphoned again inside and so on. So this is my personal feeling and my view on that. Thank you.
Thank you, sir. Thank you so much. Malhotra, sir, your final take on it, please.
Yeah, yeah. Thank you, Dr. Nitin. Now, I would only mention, unlike Dr. Pillai, I will start with renewables. So, see, very rightly, government is pumping some money. I will not say great deal of money, some money into the renewables. Okay, things are improving. Definitely, things are not as they were 5 years back. I think somebody mentioned sustainability within the sector. See, one thing is, you are producing electricity, how sustainable it is for the environment, etc. I am talking of sustainability within the sector. you have put up a plant, whether it is solar or wind or nuclear or thermal, any kind of electricity generation plant, you make a capital investment into that. And after that, you have to see to it that it sustains. Your investment sustains, the plant availability factor remains relatively high. I have particularly seen in the case of wind, I had the great fortune of visiting various parts of India, and I will not take the name of a place, but I visited a very large and popular solar PV farm. With maybe thousands of windmills were there, and of course, it was a very nice photo opportunity for me. But more than that, I was interested in counting that how many of them are actually rotating and how many of them the blade is broken, or how many of them only the pillar is there, but the pens are missing or the turbine is missing. So I was making a count of that, and in fact, I found out, by a small sample size, I concluded that, at a given time in every square kilometer, probably around 40 to 50% of the windmills were not working for a reason, for some or the other reason. Either the blade was broken or the turbine had fallen down or um, they were not working. Similarly, I have seen in case of some solar plants, it is very nice. You dump some money by borrowing, by taking from government, or by generating your own funds. You buy a lot of solar panels. I have seen even in case of some rooftops. With great enthusiasm, they will put the solar panels. But they should know that having put the solar panels, it is their duty to clean them once in a while, so that the conversion of the solar insolation into electricity, there is certain design value. That design value is not permitting a thick layer of dust on the solar panel. So I think these are some issues in renewables where we put up the capacity, then we have to maintain it. We have to see to it that they are operational, the availability factor is there, and the capacity factor. Already renewable suffers with low capacity factor. So even if availability factor is 100%, for example, in solar, the best capacity factor you can have is 20 to 25%, not more than that. Similarly, in the case of wind, it could be even lower, because if the wind is not blowing, you can't really help it. So in that, there should not be added uncertainty of availability factor. If the availability factor is 100% or close to 100%, at least whatever capacity, whenever it is available, as long as you have sunlight, your solar plant should work. As long as you have wind blowing, your windmill should keep rotating. Similarly, it is true for nuclear also. If we have put up the plant, see, in the beginning of our nuclear power program, I remember when I was 20 years old, we were just putting up reactors. Our downtime used to be very high, and our tripping used to be very often. Now, long years we have come off that. Today we have nuclear power plants. We have the world record. Kaiga plant, we have the world record, that longest uninterrupted operation. So I think that is what is important. One is to manage money for capital investment, and then do justice with that statement by ensuring long availability factors, high capacity factors for the plants. I think that is the crux of the issue. When money is less, we should know how to manage with lesser money. I think that is a very important lesson. And as far as government planning, yes, they should concentrate for the capital investment in the nuclear sector, in the renewable sector. And I think another thing which I would say to my colleagues in nuclear industry also, I am pained. See, in 2011 we launched 4 reactors of 700 megawatt each. In fact, we at that time I was the official states spokesperson of Department of Atomic Energy. So very proudly I announced. In fact, even to audiences outside India, I very proudly used to tell them, India is the first country which took the bold step of launching a new project immediately after Fukushima. Fukushima happened in March. In June, we launched 1 reactor. In August, we launched another one. By December, we launched 2 more. So these 4 projects were, I was very proud, and I used to calculate that out of these 4, at least 2 of them, before I superannuate in 2015, probably they will be completed. And why I used to think so? Because we had done it in 2004-5. In 2004-5, Tarapur 3 and 4, we had completed in 48 months. So all the more reason for me that from 2011, at least 2 reactors we will be able to commission by 2015. But I think that remained a dream. Fortunately, after retirement, I was offered re-employment for 3.5 years in DAE. I thought in those 3.5 years, some of these reactors will come, but still they didn't come. They came only after. In 2019, I laid down all my offices with Department of Atomic Energy and became a true pensioner. And now only in 2020, as you know, one of the 4 reactors became critical, has been connected to the grid, and is expected to be declared commercial in coming March, maybe next month or so. And other 3, again, they are not committing anything. I don't know when what will happen. So I think this is in a way, I mean, my own colleagues, but I think it is a criminal waste of the money, people's money, which has been given to you. I don't think by any means we should take 10 years to complete a reactor. It is not permitted, should not be permitted. Once we are telling fleet mode, I think all these reactors in true sense should be completed in 4 to 5 years. So I personally feel the 10 reactors, when in fleet mode their construction begins, all the 10 reactors should be online within 6 years. This is my personal feeling. I think not only to nuclear sector, in every sector, the gestation period, the project management has to be such that the gestation period has to be brought down to the thermodynamic limit. I mean, people should be able to say confidently that as per thermodynamics, gestation period of less than this period is not permitted. We should be playing in that range. I think with that, I'll close my remarks.
Thank you, sir. Thank you so much. Thank you, all of you. In fact, all of you have rightly mentioned, like, if we really want to achieve the sustainable development goals in terms of energy security for our country, we need to pursue this very strictly. The standardization, which all of you has mentioned, it is very important, and the execution of that project management level is very much required. And with all these word and understanding, I would like to close this session and forward the conversation to Dr. Deshmukh, who will finally conclude the session. Thank you, all of you, for answering these questions and
Thank
taking
you.
this intrigue discussion on part. Over to you, Dr. Deshmukh. Thank you.
Thank you.
Thank you, Jitendra Singh. I am here now to present you vote of thanks on the occasion of this national conclave on India's sustainable development, and we had very good speakers and panel members and experts. First of all, I would like to thank the chief guest and from Industry, Sir Barua sir, for his exciting talk and giving direction to this panel discussion, which could rise to many subjects and different areas. And I'm also thankful to Pillai sir, who happens to be in several other programs also along with us. I remember in Someshwar also he was there, and we had a very good cycle rally and exhibition and several other things in addition to his keynote chief guest keynote address as the chief guest also. And we are always uh, interested to work on several fronts under his directions. So there is a big team of students, faculty who are always motivated, and they remember our event even in Someshwar area. Now this is a Fulton event, and we find that this is also very much successful event. We covered several topics. So thanks to Pillai sir for his special guidance on several topics, including sustainable energy calibration, standardization, and several other aspects. In fact, it is really difficult to cover in such a short span of time, but we know the kind of guidance and the kind of the contribution they have, it has made it possible to cover so many points in this conclave. Then I am thankful to Mr. S.K. Malhotra sir, who is Secretary of Indian Nuclear Society. In fact, for his information, we conducted several programs for INS as well as some programs for BRC program, and we are really delighted to listen to you today for throwing light on several topics under not only nuclear but several other things also, including education, which has really given very good direction to people who would be conducting other programs in future as well as working on several fronts. I'm really thankful to Malhotra sir, and definitely we take it forward. In fact, I'm also a member of INS, so that's why I'm always connected, and sometimes I must have met him and heard also through several of his sessions, through conferences. And then I'm thankful to Anuj Bhatnagar sir, Deputy Director of Bureau of Indian Standards, for throwing light on several important aspects of measurement, calibration, standardization, sustainable energy. And I think the core values could be brought through whatever he has said for all the verticals, not only nuclear but several other. We know measurement and instrumentation, even though it finds a lot of importance, a very less number of trained people are available even today, and we always face challenge. Even in fact, I am also belonging to instrumentation, so I know kind of challenges which we have because the industry is diversified, the number of industry are more, and they look for very good engineers. In fact, the major challenge is to produce such industry-ready engineers, in fact, in general. So we learned many other important aspects through his directions. Then we are thankful to Dr. E.N. Oza, so National Physical Laboratory retired scientist, and he has given very important ideas, and he has shared his experience on many aspects of sustainable development in India, specifically related to industry and not only nuclear but many others. And even in education also, there are some of the important challenges which he has mentioned. And of course, Nitendra Singh, he has taken maybe timeless efforts for several months for organizing this conclave. So I'm really, I want to acknowledge thanks to him also and his team, Dr. Rajiv Singh, of course. We were discussing on several during several online meetings to prepare for this program. So his contribution is acknowledged here. Sunaina madam and many other people who have worked at background to organize this program very successfully, and some of my faculty members who were working for making this program successfully at Fulton College of Engineering. So I am also acknowledging thanks to all of them. Plus, it is very important that the audience which they're there with us on YouTube, and they will be also coming in future on YouTube to listen to this program. And we have really sent questions. Those were very important questions. That is what I feel, and the kind of discussion which we had at the end of the speakers' overviews on different aspects. So it was very exciting to know that the questions were also very good. So we really acknowledge your effort to send the questions. At the same time, all the audience and anybody who has remained to this list, or anybody who has worked at background level behind the screen, and for all the efforts which are required for successful completion of these programs. I acknowledge thanks, and special thanks to IYNS, Indian Youth Nuclear Society, as well as Indian Nuclear Society, and our Pathan College of Engineering, and similarly many other people who have supported. So, in fact, overall it was a very good program, and I also declare that this program is concluding. But before, I just wanted to hand over the session to the organizers if they have any announcements. So over to Jitendra Singh and organizers. Thank you all of you.
Thank you, sir. Thank you, all the guests, all the panelists, everyone joining here. Thank you so much. Uh, I think this session is over.